Okay, page 2 of quadratics. So first we're going to start with some strange looking equations here. It says solve for x, but it's like, oh my god, I don't know how to solve this. Just remember that like if you have a bunch of x's and they're just squared or single x's like this, eventually you can multiply that out and expand it and simplify it, and then eventually it's going to turn into a quadratic. So we're just going to expand that, we're going to expand this, and then eventually we're going to get a simple quadratic. Okay, and so I'm going to move everything to the left side, right, so that I have just 0 on the right side. So I'm going to put like negative 2x squared for both sides, so it's going to give negative x squared. I'm going to add 5x to both sides. It's going to give me 7x. I'm going to subtract 11 from both sides. It's going to give me minus 10. Okay? And then I got equals 0. And so I'm already there where I was before. Now, if I wanted to factor this so that I can figure out what the values of x are, then I put like negative x and x, right? And then probably 2 and 5. That's kind of the most common factors for 10. So now I made one of them negative, one of them positive. I just guessed one and the other. So then 2 times x gives me 2x, positive 2x. This negative 5 times negative x gives me positive 5x. So positive 5x plus 2x gives me positive 7x. It worked out. Okay. So now I'm just going to figure out what the value of x is for each of these. So this would be negative x plus 2 equals 0. So x equals 2. This one, it's going to be x minus 5 equals 0, so it's going to be x equals 5. So those are the two possible values of x for A. Now let's do C. Again, C looks like kind of a mess, but actually all we need to do is multiply everything out. Eventually it'll turn into a quadratic. So 5 minus 4x squared equals, and then I'm just going to expand it. So 3 times 2x plus 1 plus 2. So it's going to be 6x plus 3 plus 2. Okay. 5 minus 4x squared. And then I'm going to move everything to the left side. So it's going to be negative 4x squared minus 6x. And then I have 5 here, and I have 3 plus 2 here. Wait, 3 plus 2 is 5, so I have 5 on both sides. If I subtract 5 from both sides, I get 0. Okay? So negative 4x squared minus 6x equals 0. This is an easy one to factor, right? If I factor out the x, I'm going to have negative 4x minus 6 equals 0. So one of the solutions is x equals 0. The other solution is negative 4x equals 6. X equals negative 6 over 4, which is also equal to negative 3 over 2, for those of you who are pretty good at reducing fractions. If you're not, that's one thing that IB really doesn't care about, reducing fractions. So you're in luck if you're bad at that. Okay. So those are the two solutions for C. What about E? So E, now that doesn't look like a quadratic at all, does it? But it is. So we don't like to have x's in the denominator because we don't know what to do with those. So what you do is you multiply everything by x to get it out of the denominator. I'm going to multiply the left side by x. I'm going to multiply the right side by x. That's perfectly legal. It's still equal to each other, right? So I'm going to get 2x squared minus 1 because x divided by x is 1, and then I get equals negative x here. I'm going to put everything on the left side. Okay, and then I'm going to factor. So I'm going to get 2x here, I'm going to get x here, then I got 1 here, and I'm going to make them both negative just to start out with. I'm going to make this one positive and this one negative because my experience tells me that that's right. So let's check that. Negative 1 times x is negative 1x, 2x times 1 is positive 2x, and I add those together, and I get x, that's the middle term, and that works. So now I'm just going to find the solution. So 2x minus 1 equals 0. The solution to this is 2x equals 1, so x equals 1/2. And the other solution is just x equals negative 1. Okay? So they look more difficult than the other problems, but essentially they are the same type of problem. Okay? All right. Now we're moving to something that may bring back terrible memories for you. It's called completing the square. Okay, they're going to start off with an easy one here. Okay? You're thinking, man, I can't use the null factor rule here because it's 2 on the right side instead of 0. But you can do a trick, which is if you have a perfect square on this side, you can take the square root of both sides, right? What if I took the square root of this side and take the square root of this side? They're still equal, right? So if I take the square root of x plus 5 squared, the square root is going to be x plus 5, right? And then here I'm going to have square root of 2, okay? And then, oh, by the way, I just want to make a correction here. When you take the square root, it could be a plus square root of 2 or it could be a minus square root of 2. So you got either one of those, right? Then you're going to have x equals, and then you subtract 5 from both sides, negative 5 plus or minus the square root of 2. And so there are two solutions to this. One of the solutions is negative 5 plus square root of 2. Square root of 2 is about 1.4, so it's about negative 3.6, okay? Or negative 5 minus square root of 2. Now, you might say, well, why don't you write negative 3.6? Because it's not exactly negative 3.6. In fact, it goes on forever. Square root of 2 is an irrational number. The digits go on forever. So negative 5 minus square root of 2 is the other solution. That would be about 6.414. It goes on forever. Okay? So those are the two solutions. Compactly, we write both solutions like this. Okay? Negative 5 plus square root of 2 or negative 5 minus square root of 2. Okay, let's move on to C. Look, this is another easy one. All we need to do is take the square root of both sides, so let's do that. The only tricky part is to remember that when you take the square root of 8, it's plus or minus the square root of 8. We don't know if it's the plus square root of 8 or the minus square root of 8. Like, for example, what's the square root of 4? What number can you multiply together by itself to get 4? Well, there's positive 2, of course. Positive 2 times positive 2 is 4. But you can also multiply together negative 2 times negative 2. That also gives you 4. That's why we have to have plus or minus square root of 8, because negative square root of 8 times negative square root of 8 also gives you positive 8. Okay? Alright, so now all we need to do is add 4 to both sides. We get x equals 4 plus or minus the square root of 8. Okay? And then you're thinking, wow, I didn't remember completing the square being so easy. Well, it's because they're kind of starting us off with easy ones. Okay? Okay, now these are slightly harder. Okay? Now here, it's like almost like it is there. The only problem is this nagging plus 1 here. How do I get rid of that? Well, what if I just like subtract 1 from both sides? Then I have x plus 1 squared equals 10. Now I'm back to where I was. Now I'm going to take the square root of both sides. When I take the square root of both sides, I'm going to get x plus 1 equals plus or minus the square root of 10. Now I have x equals negative 1 plus or minus the square root of 10. Okay? Alright. E. I have this nagging 2 here. What do I do with that? Well, I can divide both sides by 2. Then I get x plus 3 squared equals 5. You can see that my objective here is to get a square here all by itself, like I do here. Once I do that, I'm home free. Take the square root of both sides. I get x plus 3 equals square root of 5. And then I have, plus or minus square root of 5, sorry. No matter how experienced you are at algebra, always possible to make these careless mistakes. So, okay. Last one. Ooh. Now this one, hey, look, I have 0 on the right side. Does that mean I can use the null factor rule? No, I can't, because to do the null factor rule, I have to have something times something. Here I have something minus something, so I cannot use the null factor rule. Okay? So first thing I need to do is to move the 7 over to the right. Since I have this nice square over here, guess what? Okay, I can I can take the square root of both sides. Okay, plus or minus 7. So I'm going to have negative 3x equals negative 1 plus or minus square root of 7. Now I'm going to divide both sides by negative 3, so I'm going to have x equals negative 1 plus or minus square root of 7 divided by negative 3. Okay? And I think that's it for page 2.